Okay, so we have special logarithms, and those that are log base 10 are called common logs, okay? So those have a special name called common logs. And why do we call them common logs? Well, because that's really how we use logarithms in the real world, right? We use common logs because our calculators, first of all, our calculators do common logs. So if you look at your calculator, you'll see it'll just say log, right? It won't say log base anything. It'll just say log. And that's because we use common logs. And so basically what it's saying is all of them are log base 10. And so since we know that they're common logs, we can actually use our calculator to evaluate. Okay, so that's what we're going to do for example 4 is it just says use a calculator. So I go to my calculator, okay, hit the log button, I do log, and then I'm just going to put in 5. And when I put that in, I get some decimal 0.69, yeah, we'll say 90. We'll round it to that, right? Okay, and it says 10,000. So tens, hundreds, thousands, 10,000, 4 decimal places, right? And so if we do 4 decimal places, it's pretty accurate. Okay, let's try the next one. Next one is log of 0.3. Okay, and so put that in, and I get negative 0.5229. Now, why do you think it's going to be a negative when I put in a number that's less than 1? Well, remember, okay, this is log base 10. So to get something, to evaluate it and to get something that's going to be less than 1, we're going to need something that's smaller than 1. So 10 to the something smaller than 1 is going to be this. And so we can do that. Okay, so those are special logs called common logs. Okay, we also have something called, exponential functions, base E, they're called natural logs. Okay, they're called natural log. But when you look on a calculator, you're actually going to see this button, ln. So why is it ln, or why do we use ln instead of natural log, nl? Well, it's actually because it comes from the French word, which is log natural. And so that's how we get ln, right? Little fun fact for you, okay? All right, so basically, okay, natural logs mirror regular log, or they look very similar to exponentials that are base E, right? And so if you look, they're the inverse, right? So they're the inverse of it. So if you look here, all right, this is e to the x power and ln of x. So you'll notice that e to the x starts at 0, or starts really low. Its asymptote is x equals 0, or y equals 0, excuse me. And then it goes up exponentially, right? And it crosses at 1e, or 0, excuse me, it crosses the y-axis at 0, 1. Natural logs, its graph, is the inverse of it, right? And so it actually starts at, its asymptote is x equals 0, and goes up and crosses at 1, 0. Okay, so opposite, right? Inverse. Instead of 0, 1 on the y equals e to the x power, it's 1, 0, which is ln of x, right? And then negatives are a little bit different. So what ends up happening is it just kind of shifts a little bit. It's kind of goofy, but anyway, we'll look at these. Your calculator graphs them. That's kind of nice. Okay, so let's check out example 5. Okay, so example 5 says, write each exponential equation in logarithmic form. So remember, natural log, ln, is equal to basically like log base E, right? Log base E, but we call it ln. So this one is going to be log base E of x equals 8. So this is going to be ln of 8 equals x, because think about it, if we think about our loop rule like we did in the last video, e to the x equals 8, right? So we can always check our answer. So this is saying ln of 8 equals x, okay? All right, so let's try the next one. It says e to the 5 equals x. So again, this is natural log, which is log base e. So ln of x equals 5. Now, how can I check to make sure this is right? Well, what I can do is I can do like, okay, this is like base e to the 5 equals x, which we know to be correct, right? So our answer is just going to be ln of x equals 5. All right, let's take a look at another one. And it says write each in exponential form. So now we're going the opposite way, right? So if we think of this, it says ln of x is approximately 0.7741. All right, so we think of it as like e to the something equals at the loop rule. So it'll be e to the 0.7741 equals x. So that's our first one. Okay, that's letter A. Letter B, okay, letter B is going to be e to the x equals 10. Now, how can I figure that out? Again, base e to the x equals 10. All right. And that's what we're going to look at in this video.